So often when I come across something like this, I see tangents and secants together. I wonder if it would be, I could simplify it algebraically before I take the derivative. At the moment, to take this derivative, if I just do it right away, I have to do the product rule and the quotient rule together. So that's a bit complicated. Could my life be easier if I rewrite the tangent and the secant in terms of sine and cosine? I don't know. Let's try. So I'm going to try to do some algebra first before I take the derivative. So 5x squared is just chilling out here. And then the tangent is sine over cosine. So I'm going to write it like this, sine of x over cosine of x. So there's my tangent. And secant in the denominator is 1 over cosine, which puts a cosine in the numerator. Oh yeah, look at that, bingo. Right, again, secant is 1 over cosine. If you have 1 over cosine in the denominator, it puts cosine in the numerator. And now I have a cosine divided by a cosine. And this is now just a product. So it totally is worth my while to do that algebra. Because now to find f prime of x, I just need to take the derivative with respect to x of the product 5x squared times the sine of x, as opposed to using the product and the quotient rule at the same time, which is a bit complex. So what's the moral of the story? If you can simplify your function before you take the derivative, do it. All right, product rule on this new version of my original function says take the derivative of the first part. Derivative of 5x squared is 10x. Sine chills out here for a sec. X there. And then plus the 5x squared just chills out for a sec. And we take the derivative of the sine, which is the cosine of x. And does that simplify a little, but not much? I could pull out a 5x. So 5x goes into 10x, leaving a 2, and the sine is still there. And then 5x goes into 5x squared, leaving an x and the cosine. So is that much less ink? Not really. So either of these two answers is good. And there's not much I can do with this right here. So yeah, that's it. Now, had we not tried to simplify it first, when I apply the quotient rule here, the derivative of the top is a product. So I'm just going to start that. I'm not going to do all of it. But if I had not made that algebraic observation, then the derivative of the top would have been 10x times the tangent of x plus 5x squared times the secant squared. And that's just the derivative of the numerator. The quotient rule says I have to take that times the denominator and then subtract, leave the numerator alone, and multiply by the derivative of the denominator. The derivative of the secant is the secant times the tangent. Oh my. And then I have to divide all of that by the denominator squared. And eventually that will clean up to this. Good luck. Do that if you have trouble falling asleep tonight.